All right, friends, phones away. We are going to be on page 67, but before we get to page 67, I'm going to do a mini review of writing ionic formulas. Let's maybe make that screen not so weirdly tilted. There we go. So you might want a piece of paper to write this on. If you've still got your phone out, if you could put your phone away, please. All righty. If you need a blank piece of paper, there is free blank paper at the back. Okay. So we are looking at the compound calcium phosphide. So its name is calcium phosphide, and we're going to be going backwards to find the formula. So if you remember, the first thing to do is to write the ion symbol with the charge. So let's go find the ion symbol for calcium. You'll want to have your periodic table out. So here we are on our periodic table. And calcium is in group 2. So what is the charge of calcium if it is in group 2? It is positive 2. And just a reminder, if you're wanting to get enriched marks when you finally write the test, you can, at this point, maybe start erasing your charges from the top if you know them. But don't worry, if you want those charges there all the time, don't feel any need to erase them. You can just leave them there if you want them, okay? Calcium is 2+. So you know how that we've written them at the top, but if you don't want them, you can just erase them, okay? And that will get you some enriched credit. All right, let's bop back here. So we write down Ca with its charge, which is 2+. When you see the ending "ide," does that mean that you probably need to look on the periodic table or the table of polyatomic ions? Periodic table. So periodic table. So go find out who phosphide is on the periodic table. Oh, look, it must be phosphorus. Okay, so that becomes phosphide, and it is in the column that has a -3 charge. So it's going to be a P3 minus. So we go back here, and we say phosphide is P3 minus. Second thing we do is we make the positive charge equal to the negative charge. And we do that by saying, what is my total positive charge right now? What is our positive charge right now? 2 plus. And what is our total negative charge right now? 3 minus. Are those equal? No. Do we need more positives or do we need more negatives? We need more positives. So let's write another Ca 2 plus. Now, instead of having only 2 plus, what's our total positive now? It has become 4 plus. Is my total positive equal to my total negative? No. Therefore, we need to, which one do we need more of now? Do we need more positive or more negative? We have 4 positive and 3 negative, so we need more negative. So let's add another negative ion. Let's add a phosphorus, and its charge is 3 minus. That means our overall charge for negative is no longer 3 minus. It is now 3 plus 3 is 6 minus. Does my positive equal my negative? I have 4 positive and 6 negative. Are those equal? No. Which one do I need more of? We need more positive, so we're going to draw another positive, Ca 2 plus. The total positive charge is now no longer 4 plus, it's 2 plus 2 plus 2 is 6 plus. Thank you. And now my total positive is equal to my total negative. How many calciums do we have? 1, 2, 3 calciums. How many phosphides do we have? 1, 2. We have 2 phosphides. I'm going to give you some choices as to what you think the formula should be. Which choice do you like? B? I also like B. You want to make sure that you don't have superscripts. You want to make sure you don't have big numbers. You want to make sure that you're counting. This is the number of calciums, not the charge. Okay, so this one is correct. Okay. One more example, and then we'll add in polyatomics. Copper 1 oxide. Is my answer Cu bracket 1 bracket O? No. Never put Roman numerals in the formula. Have you ever seen a Roman numeral in any of the formulas we've ever done? No. So no Roman numerals in the formula. Okay, so once again, yes?
On the test, do we have to write the charge? Or you can just do it?
You can just do it in your head.
Okay.
I mean, if it were me, I would be like Cu2O, right? You know what I mean? Because I've been doing this for a million years and I don't even need to think about it anymore, right?
Yeah.
So show as much or as little work as makes it useful to you. I will not be marking your work.
Okay.
Okay?
Yeah.
Okay, so copper. Copper is Cu. Now, if we go look up Cu on our periodic table, it is in the middle, and it's actually in the red zone. Okay, it's not red right now, but it is in the red zone. This particular periodic table doesn't have it red. Do we know its charge from the periodic table? Nope, we don't know its charge, but fortunately, what do we have here? We have 1. What does that tell us? That tells us the charge. So we don't need the periodic table to tell us the charge because the charge is right there. Woohoo! Okay, so here we go, and it is 1 positive. Oxide. Who is oxide? We see the "ide." Where do we look? Do we look on the polyatomic ion table or the periodic table for something that ends in "ide"? The "ide" ending is usually on the periodic table. So who is oxide? Oxygen. So let's go look up the charge of oxygen. Over here we go. There's oxygen. It is -2. So we have O, 2 minus. So that's step number 1. Step number 2 is to make the positive equal the negative. A lot of people get excited and they stop and they forget to do this, right? Along the way somewhere, they forget to do it. So don't forget, you have to make the positive equal the negative. Are they equal yet? 1 positive and 2 negative? No, those are not equal. Who do we need more of? We need more positive. So let's put another one here. So our total negative right now is -2. What is our total positive? +2. Are those 2 equal? Yes. So we don't need to add any more ions. So this would be Cu, and we put a 2 to represent the fact that we have 2 of them. And then we will write O. Do we write a little number 1 here? Do we write a number 1? No. We do not write a number 1 because we never write a 1 in a formula. Okay, we just leave it blank, and if it's blank, it means 1. Okay. Now that we've done a little review, we're going to throw in some polyatomic ions. So we're not doing anything differently. We are still finding the formula for the ion and its charge. So this is page 67. Page 67. I think it's page 67. Let me double check. 67, yes, indeed. I'll give you guys a minute to get that out if you don't already have it. Page 67. So you write the formula for each ion and the charge. You make sure that the positive charge and the negative charge equal each other. So you're balancing them out, balancing positive and negative. And then finally, once you've made them equal, you use subscripts to represent the number of each ion. One of the tricky things in this section is that there are a lot of ions that sound the same. There is nitrate, there is nitrite, and there is nitride. Ate and ite ions are on the table, on the polyatomic ion table. Polyatomic ion table. Okay, so the eights and the ites are on the polyatomic ion table. Ide is usually on the periodic table. So you have to watch out, because if you just see the nitra and you get excited, you might write down the wrong ion. You might be like nitrate, but you write nitride, and okay. Most ides are on the periodic table, but these two ides, hydroxide and cyanide, are polyatomic ions. So you'll notice when I said ide is usually on the periodic table, that doesn't mean that there aren't exceptions, okay? There are some ides on the periodic table. I'd actually like you to think about the word hydroxide. Hydra, ox. What elements do you think are in hydroxide? Hydrogen and oxygen. Okay, so we have oxygen and we have hydrogen. And actually, cyanide is kind of nice as well, because you can see that we have a C and an N. So it is made of carbon and nitrogen. So it's two different types of atoms stuck together with a charge, so that is a polyatomic ion. Okay? Okay. Let's try a couple of examples. We're going to try just over on the side here, for example, magnesium hydroxide. Magnesium hydroxide. Yes. Yeah. Please go to your periodic table and find the symbol and charge for magnesium. Magnesium is on your periodic table. So it is Mg, and the charge is 2+. Whoops, wrong thing to click. That's the one I want to click. So Mg 2+. Now, even though we have hydroxide, normally the IDE says go to the periodic table, but we know that this is the weird name where we have both hydrogen and we also have oxygen. Okay, so we know hydroxide is one of the ones. And if you go looking on your periodic table, you will not find hydroxide. You'll find hydrogen, but not hydroxide. So let's go look up hydroxide on the table, on the polyatomic ion table. Hydroxide is OH minus. And whenever it says minus, what does it mean? It means minus how much? Plain old minus means minus 1. So we have +2 and we have -1. Are those equal? 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 This is going to be quite the video with me doing that. Is 2 equal to 1? No, 2 is not equal to 1. So do we need more positive or do we need more negative? We need more negative. OH minus 1. Now we're going to have, with those two together, -2. And now our positive and our negative equal. So we need to now write the formula. Mg. Do we write a little 1? Nope. And then we write OH, and I'm going to give you 2 choices here. Do you like choice A or do you like choice B? One thing I want you to think about is when you have a 2 here, it refers only to the hydrogen, but it does not apply to the oxygen. How many oxygens do we have, though? We got 2 oxygens, so we need to include 2 hydrogens and 2 oxygens. We need it to refer to that whole thing. So anytime you have more than one of a polyatomic ion, use brackets. Okay? Okay, sodium nitrate. Symbol for sodium is Na. It's in column number 1. What is its charge? Column number 1. Charge is 1. It's in column number 1. Its charge is 1. 1 plus. When you see the ending 8, do you look on the periodic table or the polyatomic ion table? 8. Hello? Hello? Up here, please. When we have an 8 ion, do we look on the periodic table or the polyatomic ion table? Polyatomic ion table. The things I do for you guys, I'm talking like Julia Child. You guys are too young to know who Julia Child was, but she was this chef. She was the original chef on TV. She went to, and she was married to a diplomat, and she ended up in France. And she didn't really know anybody, and she didn't know what to do, so she decided to learn how to cook French. So she learned French cooking, but she had this voice that was like this, and she would talk on the show, and she would make all the food, and yes, it was quite the thing. But anyway,
How long ago was that?
Pardon me?
How long ago was that?
Ooh, it was probably even before my day, so like in the 50s and 60s. Yeah. Mid 20th century. Nitrate, we go to nitrate is here. Don't forget you have to write that 3. If that 3 is missing, it is not nitrate. NO is not nitrate. NO3 with a 1 minus charge is nitrate, okay? NO is not nitrate. So NO3, 1 minus. Do our charges equal? Yes. So we don't need to add any more of either of them. We simply write 1 Na and 1 NO3. And again, I'm going to give you a little choice. Do we like option A or do we like option B?
Oh, it is matched.
Or do we just not know yet? We're just totally fine. Yes. You like option A? I also like option A. When we have only one of a polyatomic ion, remember if you have more than one, you're going to use brackets. But if you have only one, you will not use brackets. Oops.
How do you know? What did you get?
Just a few little more details, things where people will commonly go wrong. Things to watch out for. All the things that say hydrogen. Hydrogen carbonate, hydrogen sulfide, hydrogen sulfate, hydrogen sulfite, monohydrogen phosphate, dihydrogen phosphate. You are not going to be looking for, this is one thing, not two things. One thing, not two things. Hydrogen sulfide is HS minus. It is not H plus and S2 minus. Hydrogen sulfate is one thing, HSO4 minus. It is not H plus and SO4 2 minus. So if you think you're trying to cram three different ions together, then I want you to consider that you probably have one of these. And where do we find those on the polyatomic ion table? Well, the nice thing is that all their names are really long. So if we look at the whole thing, we look, where are the long names? Here's some long names, yes? So HCO3, you can either name it hydrogen carbonate or you can name it bicarbonate. It's a choice, okay? And it's just one thing, so you can look it up there. So if you see hydrogen sulfite, it is HSO3 minus, not like some weird combination of the two. And here's another one that messes with people. It messes with people. It messes with people because it's got a dye, and people think, oh, there must be two of them, but it's not. It's just confusing. I'm sorry. That's what it's called. There's nothing I can do about it. The only thing I can do about it is say dichromate is not two chromates. Let's go look under D on our table of polyatomic ions and actually look up what is dichromate. What is dichromate? We look under D. Dichromate is not two chromates. That's chromate. Yes, this is dichromate. And there's only one of them. Okay, so don't try and make it two chromates. And lastly, I would like you to look at this formula right here. And I would like you to tell me what these three letters are. Yes. Yes, you may. But before you go, you need to tell me what those three letters are. What are those three letters? Okay, everyone who's working ahead, you need to be quiet for a moment so that people can think. Okay? What's the first letter? What is the first letter? Yes. The first letter is not cation. The first letter is just C. Okay, the first letter is C. That's all I'm looking for. What is the second letter? Is that an I or an L? That is an L. Okay. And then we have an O. So it is ClO3, not CiO3. This should make sense because you will have been given the name chlorate. You go and look it up. If you have a name that has chlor in it, you should have the symbol for chlorine. It is not carboniodate. Yes? There's no such thing as carbon iodate. It is chlorate, therefore it is Cl for chlorine, not Ci for carbon iodine. Does that make sense? You will always, 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 remember I promised you, your eye will always have crossbars. Okay? And that's not what we have. Okay? I think that's it. So you guys are going to now try some of those questions on your own. Okay? Give it a go. And if your name is up here, if you don't manage to finish your quizzes today, I would like, if possible, for you to come into Flex tomorrow. And if you can't come into Flex tomorrow, talk to me. We can arrange a different time. Okay? So if your name is on the list, your options are A, finish the quiz in class today. B, come into Flex tomorrow and finish the quiz, work with me. Or C, let me know a different time that works better for you. Okay?
No, I can't have a math class. Oh, shoot. No, that's just too.
Yes. Yeah.
It's not on the test. It's organic.
Yes.
Not on the test.
Yeah, there's an
The
extending.
organic? No.
It's just like.
What about on the extending?
I don't want to bother. I got a lot of other stuff happening. I don't want to make up that part of the test. To be honest, that's what's going on.
We should have 4 questions.
Right. Yeah, then we all.
Try something.
So you need to decide for these ones, ionic, no prefixes. And for molecular or covalent, prefixes. So you have to decide which one is which. Do you know how to tell? Okay. Yep. Baran.
You didn't believe in me.
Thank you.
Yo, Brian, what is this?